Well, hi, good morning. Thanks so much for joining me here in my shop. It's November 3rd. This is day 2 on this Magnavox radio. Day 1 was about 6 or 8 weeks ago when I looked this over and unfortunately started thinking, oh, these tubes are not the right tubes that are in here, especially this one. This is a very special gas rectifier tube. There's no need for a rectifier tube to be in this radio. There is no power supply in here. This is a battery operated radio. So, in fact, I really reached the conclusion that probably none of these tubes are right. This is a 26 or 226. And this one, I can see Ontario patented something or other on. Oh, here we are, 226 down here. Radiotron UX 226. Diatron. Products company, never heard of them. Diatron. And what tube are you? There's an 18 written in here, but I don't know what the 18 means. Well, I don't know. Don't know what tube that is. That's just as good as it being the wrong tube. I don't know what it is. Now this one looks like it might be correct. This is a no. This is a 226. A 26. That's probably a measurement somebody made. 450. It's probably the transconductance of it. So after posting the first video on this, not knowing what I'm going to do with it, I got a note from somebody saying, hey, you're right, all the tubes in there should be O1As. Well, I don't really have a good set of O1As that I can put in this radio, but guess what? The owner of the radio did. He managed to scrounge some, so I have a set here. I think I actually have 6 tubes in here. 1, 2, 3, 4, 5, 6 tubes. I think they're all O1As of unknown quality, and that's what's needed to make this radio go. So today, since I got such a late start in here today, I think I'm just going to concentrate on testing these very old tubes. Now, these tubes are old enough that they can become gassy. They're more likely to become gassy than other tubes. So it's got a note 50 on it. SER, sir. This looks like my writing, but that's not from me. And this is a 201A. So 01A, the first number 2 denotes the manufacturer. I have a feeling there's only one manufacturer of these because they're all 201As. Okay, so I gotta decide now which tube tester. It says sir again. Maybe that's the name of the radio. $50. I don't know what 50 is. Serenader. Okay, here we come. These have come from the Serenader, the radio, another radio. Just kind of borrowed these out of one radio to see about making another radio operate. What's this one? Radiotron. Oh yeah, UX 201A. Don't think the UX means much either. 201A. Serenader. 201A, and this last tube from Les. 201 from top. 201A. Westinghouse. Radiotron. Maybe that first number doesn't denote the manufacturer, unless secretly what's going on is they're all made by the same company. Radiotron. I don't know. Complicated history on these guys. Very, very complicated history. So I'm going to figure out how I can test those, which tester to use, and I was mentioning gas in them. So I've read that it's a good idea before, yes? What's the problem? Yes, it's cold outside. It's too cold to go outside today, so it's -4 outside right now. So these could have gas in them. And what I learned is the getter, which is what's caused all of this to be mirrored here. There's a lot of getter chemical on the inside of the glass here. Only works well when it's hot or heated up. So the idea is when you get an old tube like this, it's good to heat them up and leave them running for a while. And under hot conditions, the gas inside will tend to find its way to the getter and become absorbed by the getter. That's a very strange thing right there. That's on the inside of the glass. And then leave it for a while. I don't know how long a while is. Half an hour, an hour? I don't know. And the idea is a lot of the gas will be absorbed into the getter. If you fire up the potential in here on the plate and the cathode in that, some of that gas will find its way to the cathode in particular and contaminate the cathode. That's what I heard. I don't know if it's true or not. Certainly these are old tubes and I don't think they've been operated for quite a while. What harm would it be to operate them? They only have a certain amount of life, but without any current flowing off the cathode, I don't think you're wearing the cathode out at all. So maybe I'm going to follow those instructions too, and heat each one of these tubes up for a while with the tube tester before actually testing them. Okay, which tube tester? Let's get going. Okay, so I'm going to use the Weston 981 tube tester. There's the booklet for it. Tube checker, and in the booklet is some more tube types because the roll chart doesn't go back that far in history, but this does. Right at the very first tube is a 01A. There's the settings: filament 5 volts, signal level 2, 22H. Check 2, 22H, and then the switches are set 63500, 63500, and then 7000. This is set to 42, and the plate is on D. We're all set here. So I'm going to take one tube. Let's start with the one that's from less. Okay. Oh, these pins are bad. These pins are really rusty. I don't normally come across such rusty pins. Let's give it a try anyway, as it is. Okay, it's in. Flip her on. Okay, you can see it warmed right up. Okay, so my plan would be to just let that sit there like that. You notice how bright these are, these tubes. Okay, almost like a light bulb. Many other tubes, newer tubes, you put them in a tube tester like this, so you can barely see the element. But this one's really bright. Let me see if we can get a really much closer look at it here, because I'm going to leave it running here for a while. So it's a little too bright for the camera, the way the camera's set. You can see the grid wires. You see the structure of it. Let me just see if I can get control of that camera here. Just bear with me for a moment. I'm just bringing up the camera dialog box. is we're going to turn the brightness way down on it. Way down. Way down. I'll try looking in there now. Don't know if that's enough. I still really can't see the element. It's just too bright. So, looking again with the other camera, maybe we can see enough of that. So the element in here will be a tungsten filament, not much different than a regular light bulb, in fact. Tungsten, of course, can take the heat, which is why it's used in light bulbs that are glowing white hot. Doesn't mean much to a piece of tungsten, I guess. In the case of the tube, you have to get it that color, that hot color, in order for it to emit enough electrons. Each kind of material that's used in the making of a cathode has a different propensity for letting go of electrons. And as time went by, scientists and engineers discovered better and better materials that could produce voluminous numbers of electrons at lower and lower temperatures, which is why they don't glow with a yellow glow now. They glow with a dark reddish color glow, much lower temperature than that. Well, I think this might take a long time to get warm. It's icy cold. If it's ever going to get warm. I'm helping along here. 5 volts on this heater. Don't know the current flow offhand. Okay, I feel kind of sad letting a tube just sit there and burn away, not doing anybody any good. But I think I'm gonna do that. I'm gonna follow the advice that I picked up. It's just gonna take forever to heat up, I think. And what we're trying to heat up is the glass. That's why I'm putting my hand on it. Almost need like an insulating tube over top of it, but even that's going to take a fair bit of time. Okay, we'll let it run there. Time check, 11:05. Boy, I pretty much forgot about this. So it's been half an hour. Now, how hot is the glass here? It's room temperature, so it's a little hot in the top here, but yeah, not getting very hot. So leaving it on is not going to help much. Let's give it a test. So for this tube, there's a warning that there'll be a short circuit indicated in one of the short circuit tests. So this needle is liable to go all the way in one spot. Probably the number 1 right here. Yeah. So that's normal. Now we're going to measure the mutual conductance of this tube, which was supposed to be 5 something. 520 is the rejection point. So 520 is way down here. So as long as we can get above that, we're golden. There we are. It's good. Good tube. Okay. That's Les's tube. Now we're just going to switch on to another one here. First thing we see is it's not heating up. That's a pretty strong indication of a dud tube. Just making sure. Yeah, you know what? There's a very faint glow inside that tube. Very, very faint glow. You can't see anything but the green light. I can't see anything at all. I can see a faint glow through here. So we'll give it a test. Here we go. Okay, so the short test is normal. without waiting. Here we go. Well, that's quite interesting because I cannot see the element, but it's testing better than the last two. So it's two good ones. Two good ones. Okay, I'm going to try another one. It's the very same as the last one. I cannot see anything through the mirrored effect here from the getter. I can see a little bit of light through there. Okay, once again, we're not going to wait. Okay, here we go. Very good. We need 5 of these tubes to make this set operate. This one appears to be the same. Checking for shorts. All normal. Quickly shoot here. Uh-oh. Oh, okay, might have been my switch. Well above 500 also. All these tubes are testing pretty much the same, which is really kind of surprising in a way, isn't it? Here we go. Now these tubes become, they're ready to operate very quickly because the filament heats up like that, and you're driving the tube current right off the heater, right off the filament. So as soon as it's hot, it's ready. Another good one. Very good. Excellent. One more. One more. So I actually have one more than I need. 40. I don't know what 40 means. 40. You know what this is probably this has been in an emissions tester. And the emissions tester is telling it 40% of what a good tube would be. 40%. These other ones all had low numbers too. 50, 50, 35. Boy, it just looks like my writing. There we go. Okay, normal short response. And another good one. Excellent. Okay, so I've got more than enough tubes. More than enough tubes to make this radio operate. So, the next thing to do with this radio. Yikes. Now that's skilled camera work. If you've ever seen some, look at that. Fantastic, eh? The next thing would be to learn how to power it up. And that means studying the schematic. And down here is the power input socket. I don't have the matching wires for it or anything. So I got to figure out how to hook up to that. Also, it doesn't take banana plugs. It's a weird size. Got to come up with something. Then we got to power it with 2 power supplies to make this guy operate. I think maybe even 3. I'm not sure. So the radio arrived here in my shop with this diagram included with it, and that's obviously the connector we were looking at a moment ago. And you can see there's the key mark for the connector. If you look at the connector, you can see in the middle there's a key. So this is somebody's information on what goes where. You can see B minus and B plus, B minus and B plus, A minus and A plus. That's fairly straightforward. Ground is straightforward. Antenna is straightforward. This is not. B plus detector. Why on its own pin? Why would this have its own pin? Some reason. So let's take a look at the schematic here. See if we can figure this out. Okay, so unfortunately my little inset there is covering part of this, but not to worry about it. So this sheet is covering 3 different models. The Model 1 dial, Model A, and Model D. I've got Model D at the bottom here. This is my radio here. And over on this end we can see the voltage inputs and outputs as shown here. Let's zoom in on that stuff. And then we got to relate it back to that diagram. So let's see, at the very top we have output. Those terminals are not part of this socket. The output terminals are elsewhere. Then we have a ground tied to B minus. F must stand for a fuse. And then we can see an A minus. And I don't know what's going on there. Just in this area here. What is going on here? Very strange symbols. These curved pieces here. Not sure what to make of that. Then we have R2. They put the they don't use a subscript here. They use it like it's R squared. Down here we have A, B, and B detector. Oh, okay, so here's the reason. Why wouldn't they just take the detector B plus and just hook it onto this line? What do they hope to achieve by having it out here like this? It's a different voltage, maybe. Maybe it's a different voltage. So can we read here? Battery switch, condenser on control unit. Condensers on control unit. Grid condenser, bypass condenser. They make the electricity denser. That's why they're called condensers. Grid leak 5 megohms. Volume control 10 ohms. Fixed resistor 1 ohm. R2, that's this guy. That's 1 ohm. Oh boy. Toroidal coils, hard to say. Fuse. Half amp fuse. Where's that located? I don't remember seeing a fuse in this radio. Well, according to this diagram, it looks like you hook up the supply here, and also you put a ground on here. This is A minus, B minus. Again, why aren't these the same? Aren't they not electrically the same thing? What are they trying to show here? They just put a B here. It doesn't say B plus. B plus. So we come on this wire, B plus amp. Come up this way. See, it goes right through the speaker to reach the plate. Like these radios don't use 8 ohm ordinary run-of-the-mill speakers. No. You need to have a proper speaker designed for this kind of radio. Fairly high impedance speaker here. It's taking a plate current right through. But that's not helping us understand what this B is. So if we follow this, this is just the B minus. You know what? Maybe they just failed to write a minus there. B. What is all this? It's just not coming through to me what all this stuff is here. Look at this piece. Just kind of comes out and goes where? Nowhere. Don't know what that is. That's a problem. I don't like not knowing this kind of stuff at the start. But you have a separate B plus going to the detector. Now all these tubes are the same tube. So they should all take the same B plus. Not necessarily though. It sure looks like it does. I don't know what to do here. So I have a single power supply. I can drive a B plus voltage onto these two terminals coming from the same supply. They don't picture the batteries here, but I think they do on one of these other ones. Yeah, this one they actually picture the batteries. 60 to 90 volt battery, B battery. 22.5 volt. Is that the A battery? No, that's going to the detector, I think. Oh, so that's the hint. Maybe that's the hint. You have a higher voltage going to these other two, so a lower one going to the detector. Isn't this the detector in this radio? Yeah, these are RF coils here. This is all RF circuitry, and then we're coming in here. And then we're going out into audio transformers. So this is the detector. This must be the grid leak detector. Where's the grid leak resistor? Okay, we're looking at the wrong radio, of course. Let's go back down here. So here we go. Audio. This must be the detector. There's the grid leak resistor there. I believe that's what that would be. We have a rheostat controlling the heater temperature on these two tubes. So you can change the emission and the amount of gain basically in these two tubes. So this is probably the volume control right here. Well, it's not clear to me what the difference here is, why I wouldn't just put B plus onto both, except for that variation in the voltage. 22, I can get to 22 with a different power supply. I can't get to 90 except for my higher voltage power supply, but I can get to 22, pretty sure, a couple different ways. It doesn't say the voltage here. Just set it up above. Well, that must be the case. It must be. Now, what about this A? What's this A voltage doing? This A voltage is on each of these heaters. I think you're biasing them. A plus. A minus. Put a minus onto the grids. Yeah, through here. So you put this minus voltage, which looks like it's hooked right up to this B. I'm going to assume the B is nothing. You have a minus voltage. Well, wait a minute. You don't have a minus voltage here. I think this is hard to interpret, but because you have two separate power supplies, for sure you want these to go negative, like the grid to go negative relative to the heaters here. So how are the heaters involved with this A? So the A plus is going here, and the minus is going right. So you're getting the minus onto the grid, and the plus side of that A supply is going to the heaters, which is basically the cathode. You're not injecting it in a balanced way, they're just sticking it onto one line. Yeah, all the way through. Can't read those words or that. That could be, those are colors. Orange, red, something. Gray, brown, gray, brown, gray, brown, gray, brown, gray. Oh, it says right up here, audio frequency, detector, radio frequency. It says right here, radio frequency. The antenna gets its ground on this line here, which I no doubt goes all the way through to the ground, yeah. So if a radio like this, and you have a wire hanging out in your backyard, you actually do need the ground rod shoved into the ground. Here in the more modern world, you can connect this to your hydro ground wire, the bare wire in the cable, the green wire. but it's mixed up with all kinds of other stuff in your house, all of it carrying noise and interference. So you're going to really invite problems here with this doing that. But I don't have a rod driven in the ground with a wire coming into my shop here. I don't have that. So it might be a little tough to even get the antenna circuit to operate very well in here. We'll probably start out with a signal generator on here anyway to start off with. Well, I don't know what else to do here except set up two B plus supplies that can be operated independently, one aiming for around 25 volts and the other one aiming for around 80, wasn't it? 60 to 90? Yeah, aiming around 80 volts. In these old radios, these audio transformers are often shorted out and failed. I can't remember if I tested the ones in here. I probably didn't. Well, what do we got to lose? You can always leave this B plus out of the picture for now. Warm up the rest of the... Yeah, warm up the rest of them. Maybe that's what we start with. Getting the heaters going. So where is the heater input going here? Where are you hooking up the heater? Well, it should be like a 5 volt heater connection. Where's that going? Is that what all this is? So here's a heater. Here's the two lines. One going to the A plus. My understanding is that A plus is a biasing voltage, not a heater voltage. The A minus is connected to the grids, not to the other side of the heater. So this must be, I don't know what's going on in this arrangement here. R2 was a huge, isn't that the 1 ohm resistor? R2, fixed resistor, 1 ohm. Is that really some kind of special difference made when you stick a 1 ohm resistor in here? And I'm assuming this is in the radio somewhere. These must represent the terminal connection points. These circles. 1, 2, 3, 4, 5, 6. We don't count the other two. If I look in the radio, 1, 2, 3, 4, 5, 6, 7. There's 7 of them in there. 7 of them. 6 noted here. Well, let's go back to that little note page. Wait a minute. Where's the note page? Okay, so we look at this now. We have the separate B plus for the detector, B plus for the rest of the radio. We have only one B minus indication. The A plus, A minus. Where's the heater current going in? What's going on here? Where do you put the heater current in? Okay, back to the schematic here. Where? What about this one? This one looks almost identical. Got that same weird symbolizing here. Reproducer. You didn't call them speakers yet. There's the A battery shown here. Okay, how do they show the heaters here? Do they show... There's that 1 ohm resistor, the on-off switch here, which is turning on and off the heaters. And a lot of these old radios You never switch the B plus, because once you turn the heat off on these tubes, they are open circuit, and so they don't conduct, so the battery can just sit there. And you have a 7 ohm resistor here, which is just controlling these first 2 tubes for volume control. So on-off switch, and then, well, it's shown across the A battery. Wait a minute, now the A battery, yeah, because they show it continuous here, that means the A battery is across the heater. I thought this was a biasing battery, the A battery. Where else could they be getting power for these heaters? Are they sneaking it in somewhere? No. It's got to be coming, well, and this doesn't show open wires. And the other thing too is this B battery, it's on top of this battery. This is the negative point here, or the ground or neutral, whatever you want to call it. And these are in series, so you're getting 60 to 90 plus 22. Funny they show this as a minus 22. Minus 22. That would make this the neutral point in the radio, and this would be minus 22 here, plus 90 there. How can this be the point? It can't be. It's just going here. Well, yeah, lots of things here to think about. How do you get power onto these? So I guess I could pick any one of these heaters and apply 5 volts to them, and that voltage will push current through all the heaters. Looks like a dual purpose battery. No, it can't. It can't be driving the heaters. The heaters are deadly on a battery. These are the power consumers in these radios. So the battery that drives the heaters is going to wear out quickly. Quite often, that was a lead acid battery. The B plus battery would last for a long time. I think this one would too. There's no way there's 22 volts going on the heater. Notice they don't write the voltage here. They didn't write the voltage. A battery voltage. That would be helpful. A battery voltage. Anybody? Any comments? Anybody saying anything about it? Any voltages written out here? Anybody give me a hint? No voltages written anywhere. Well, we know these tubes are designed for 5 volts. So could this be powering? Look once again. You have A plus here and the A minus sitting here. A minus is on this line, which goes to the grids. A minus is also here on the other side of a 1 ohm resistor, just going to this side of the heater, and the other side is hooked up to the A battery plus. Well, okay, something not quite coming through, but it looks to me like what they're doing is you put a 5 volt A battery here, drive the heaters, and somehow introduce a bias just by how you know which side of the battery system you ground. So you would tend to want to ground the positive side. No, wait, that doesn't make sense. That doesn't make sense. You want the A battery between the grids and the heater at the same time powering the heaters. Is this the where they're? This is the sneaky way of showing, and here's where the battery power goes in for the heaters. How would that work? This comes right across here. And it's on the grids. It's not on the heaters. The two heater lines. One ends here. Well, there's only one way into the heaters, and that's through this battery. There's no other connection here. I guess maybe I just don't understand what an A battery is really all about. You know what? I think I got it wrong. Maybe it's the C battery. Oh, is that what that is? C battery? Is it the C battery that drives the heaters? The C battery is the bias battery. I'm all confused now. Okay, now I don't know what I'm talking about anymore. I don't know what I'm talking about. ABC. Always be careful. Yeah. Because here they have, yeah, that's another B plus. A battery. They show no other way to power these heaters except through this battery. And the 1 ohm, right there. Okay, so now taking this information, considering what's up on there, no voltages written on a little piece of paper. Well, I guess as we would power up the A spot with 5 volts, the B spot with 80 volts, and the detector B plus with 20 volts. Man alive. Okay, I gotta set all that up. Okay, I think I got one thing sorted out here. A battery, C battery. Just shame on me for getting confused. But so this is a DC supply you can run old radios with, and it comes with 2 voltage outputs, one here and one here. This one is called B plus output, goes all the way up to a couple hundred, 300, 400 volts, and can drive out 100 milliamps. Now this is to power the 2 plates. Over here is another output called C minus. This one is good to 100 volts, minus 100 volts, only 1 milliamp. This is for setting up bias. And what about running the heaters? Well, this particular supply offers 6.3 volts here to run heaters, but that's not what we're looking for. In this radio, we're looking for a DC supply of 5 volts for the heaters. So A is the heater battery. B is the plate battery. C is the bias battery. There is no bias battery in this radio, but that has to be the case here. And I just kind of got my A's and C's a little bit confused there. Okay, I'm very hesitant to do this because you make a mistake, destroy the tubes that are in here. So you don't want to make a mistake on this kind of stuff. And I'm good at making mistakes, so I gotta be doubly cautious, triple cautious. Okay, so I've decided the first step is to get the heaters operating in the tubes, and to do that I need a fairly high current 5 volt supply. So each tube draws about a quarter amp, 5 tubes, so it's a little over an amp. Not too demanding on most power supplies. Too much for my little guys over here, so I've had to use this big one, which is way up in behind here. So that guy will put out 30 amps. No, I don't need 30 amps. The problem with it is that you can only turn it down to just under 6 volts. So here you can see on this meter, that's the voltage coming out of that supply. Now I've been able to figure out where to hook it up using the diagram here. And I've also discovered some clip leads are pretty good at gripping the connector there. So that's a great thing. That's going to solve lots. Sending an amp down a little clip lead like this is a little questionable. There's no tubes in it. Switch is off. Watch the volt. See if it drops. Okay, so it didn't drop at all, so there's nothing drawing current. Pretty sure we would see a drop here. I'm going to switch the set on, which is basically, there we go, turning on the heaters, but there's no tubes. Looks like there's no current draw because the voltage didn't fall. Okay, so we're ready to try this now. The problem is I'm going to be hitting these tubes with a little over 5 volts. Although I think this is going to drop a bit, and I think there'll be a little bit of a drop on these wires. So it'd be better if I monitor the voltage right up here. It would certainly be better. I think I should do that. I think that would be a better move. Excuse me. So we're gonna put it like that. Make sure the switch is off. Switch is off. I'll see if I can stick these in here somehow. Can actually see through the little hole there what I'm doing, so I'm checking to see how they're completely loose and floppy in there. Put this back in the right spot. I would need 2 more clip leads to do this. 2 more clip leads, please. A little bit on the floor there. Okay, that's one. Too far. Okay, so these are the voltmeter leads now. Oh, but there's no power being drawn through this, and it's already dropped off. That's not a good sign. That's not a good sign. Well, if it drops, 4 or something like that, I'm happy with that for now. That's a good. So we'll turn the set on. Not sure what that was. Okay, set is off again. We're going to put in one of these tubes. Put it in where it's visible on the camera, I guess. Okay, so there's a little nubbin on the side there that has to go in like that. Now, why only one? I can't imagine that 5 1/4 volts is going to blow this, blow the tube. You could probably put 7 8 volts on them and they'll probably run okay. 12, I'm not so sure about that. We're nowhere near that kind of voltage. Let's put more load in. Put in more tubes. Going to draw more current. Going to pull the supply down a little further and protect the tubes that way. It's kind of a backwards way of doing it. We have no speaker hooked up and we have no B plus supplied. This is just to heat up the tubes. Goodness knows how good these sockets are, because all they are is some pads, and you push the tube in and the prong comes down and pushes on the pad a bit. And the pad is a little bit springy, so it pushes back. So the contact is like this. It's not sliding into a thing like that. It's going onto this kind of surface. And look at these are wobbly. You can see the untangle my camera. So those are the contacts, and they're just a little bit spring loaded. in a very, very simple way. So a good chance I'll have contact problems with this arrangement. As I already know, I can't see through the tubes to see if they're heating unless I turn all the lights out, which I'm going to have to do this properly. And I can't bring up the voltage slowly. It's all or nothing. So that was a funny coincidence. I was staring at my meter, which went off at the same moment my overhead light timed out. Yeah, there's some kind of timing deal going on with this overhead light, which is bothering me. It's my noisemaker light. I think it'll stay on that way, but we don't want it on. Okay, let's dose. Yeah, let's turn it off. Oh, it's turning itself off. How handy is that? Turn this one off. And when the time comes, I'm going to turn this off, and that's plenty dark. If there's any tubes lighting up, we should be able to see it. Okay, at the same time, I'm going to want to read the voltage over yonder on the voltmeter. I think I can just tip this way a little bit. Yeah, we're reading a 5-volt range. No load. I'm going to guess. I'm going to turn the set on, and this voltage is going to plummet. Probably from resistance in one of these clip leads. Something like that's going on. And the amp through these clip leads is going to heat them up a little bit too, I think. Okay, I think we're ready. As I say, there's no slow way to start this. Okay, so I'm going to turn, I got my hand on the switch here. Okay, lights out, switch on. Okay, so on, looking quite normal. And I would say 2 of them are on. 2 are on. What's the voltage? It's pretty much hung in there at 511. That's good though. How come only 2 are lit up? How do I know for sure only 2 are lit up? You can see them in the camera. At least you can see this one here. I'm blocking with my hand. Okay, so a little wiggling of the others. These things come on really quick. Is that on or is that a reflection I'm seeing there? You probably can't see what I'm doing. Okay, so 2 tubes could have their heaters turned down because the volume control may be turned down. Okay, so what about this one here? This is the... Yeah, you know, if I push it, let's take the light on here. Watch this voltmeter. Oh, we're way down. If I push this, let's see, cut in, and then let go of it, and it goes out. So it's about a 100 millivolt drop. Okay, so there's contact problems here. Now these last 2 could be they're just simply turned down. So I'm going to adjust the volume control, which adjusts the heater current to, I think, these 2 tubes, just guessing, which they are. Let's see if this doesn't react. I would guess the volume goes down this way. So we draw less current, so this current should go up. Okay, now we're going to go the other way. I don't see much of anything going on except the light I'm using is going up and down a little bit, my shop light. So I'm looking at these 2 tubes that are lit up. Are they changing in brightness? Not a bit. Okay, let's try pushing on one of these tubes. I'm watching the voltmeter here. I should really have a current meter set up to do this properly. But let's watch this. Does it drop? Let's see anything happen. How about this one over here? Oops. Oh man, something happened there, but I don't know what it was. Okay, so that's the state of affairs. We have 2 tubes heating. Let me just look in the dark again here. You know what? I think we got 3 tubes heating. I think we have 3 going. This one up here appears to be going. 3 tubes, and if we bring this one in, yeah, look at that. That definitely knocked it down. So the one that does not appear to be going is this one. Okay, this guy's in a little bit of trouble. This guy's in a little bit of trouble. We gotta figure that out. Now, turn them off. This should make the voltage go way up. Go up again. Yep. Perfect. Perfect. Excellent. I have a heater supply to work with. Polarity of the supply is important. I haven't paid attention to that yet. Okay, so I think that's going to be as far as I'm going to go today. There's a big cooling fan in that power supply. Tomorrow we'll try to sort out what's going on and get all 5 tubes heating up, and then we can proceed with applying B plus and stuff like that. Bring in a speaker. I have a speaker that's appropriate for this radio, and see if by some chance it works as is. There's a good chance if we can get the tube sorted out, it's going to work. So thanks for watching, and see you on the next video.